Hello viewers, welcome to this video. I'm Venkat and this is Just Me, an open source channel. Right, in this video I want to talk to you about something called PodPreset. It's actually a very simple thing. PodPreset is, you can think of it as a templating. So you can create a template and you can apply the template to a set of pods. It's not exactly a template, but you define some configuration that you want to apply to a set of pod, and then you deploy this pod preset resource. So pod preset is a resource that can be deployed in your Kubernetes cluster. So once you deploy it, you define which pods will or should have this configuration. So when I show you a demo, it will make more sense. I've also got notes to cover what I should be covering in this video. So first, we will be checking if pod preset is enabled in your cluster. Most likely it won't be because it's not enabled by default. You have to enable it. And then we're going to see how to enable pod preset if you followed the Kubernetes cluster installation using Kube. And then I've got few pod preset manifests in my GitHub repo. So I'm going to go through the pod preset manifests, what should be included in that YAML files. And then we are going to deploy that pod preset resource. Then we will deploy a sample app and see whether the pod gets those configurations that we defined in the pod preset. And then we're going to deploy another pod with similar configuration. And then we're going to deploy another pod without labels. So the pod preset works by labels. So when you create a pod preset, you define what pods should get this configuration from this pod preset. So that's done by labeling, right? So we're going to do a test, say deploy an app without the label, and then add the label later, and then verify whether the pod preset gets applied. And then we're going to see if we can apply multiple pod presets to a pod or to a deployment. And then what happens when you have conflicts. So it won't make much sense now when I go through this list, but when I show you individual examples, it will make a lot of sense. Okay, for this video, the infrastructure I'm having is I've got my host machine and I've set up a Kubernetes cluster using LXC containers. So I've done a video on that. If you want to know how to deploy a Kubernetes cluster using LXC containers, there's a video that you can search in my channel. If I do LXC list, so I've got kmaster, kworker1, kworker2. So a master and two worker nodes. It's all running now. If I do kubectl get nodes -o void, so all of these are CentOS 7 LXC containers, and the Docker version that's installed on these containers are 18.6.0. Right. So let's look at the version of the cluster. kubectl version --short. So I'm running the latest version, which is 1.14.2 at the time of this recording. Don't worry about the client versions. I've downloaded the kubectl sometime long time ago when it was 1.13.0, but it should work with any version of the server. Okay, so that's my Kubernetes cluster, one master node with two worker nodes. So the first thing is to check if pod preset is enabled. So how do we test? So pod preset is a resource. So if you do kubectl get pod preset, it will throw you an error. The server doesn't have a resource type pod preset, so which means pod preset is not enabled in your cluster. Okay, let's now see how to enable pod preset in the cluster. So the method that I'm going to show you will work only if you have deployed your cluster using Kube. If you have deployed a cluster using other mechanisms, I think you will have to check with other documentation, but this one works if you have done it using Kube. Okay, so if I do kubectl -n kube system get pods, so there is this Kube API server kmaster pod. The API server is running as a container in the kmaster node. So let's look at the details of that pod. kubectl -n kube system describe pod kube API server master, pipe that to less. Okay, so that's the description of the pod, and basically the pod is a container image of the Kube API server. And when you start this container or pod, it runs this command Kube API server with a long set of options. So to enable pod preset, we have to add an option, and we also need to add to this one, enable admission plugins. So at the moment there is one plugin that's enabled by default, which is node restriction. So we need to add PodPreset to this admission controller. And in addition to that, we need to add one more option, which I will show you in a minute. Okay, so how you go about updating this container, the arguments. Okay, so if I log into my kmaster, as I'm using LXC, I'm going to use LXC exec kmaster bash. So I'm inside my master machine now. So cd to etc kubernetes manifest. So this is where the manifest file, the YAML files for all the components that are running in the masters are stored. So you can see the YAML file for the etcd container. If I show kubectl -n kube system get pods, you can see the etcd kmaster, API server, controller, and the scheduler. So all these pods manifests are here: API server, controller manager, scheduler, etcd. So those are the main components that run on the master server of your cluster. So that's the basic manifest file. If you edit this manifest file, the changes are dynamic. You will see the pod will get restarted. So once we edit the Kube API server's manifest, the cluster will determine the change, and then it will automatically delete this pod and then recreate the API server. Okay, let's go ahead and do that. Edit Kube API server.yaml. And you can see the same set of command and arguments that we saw using the kubectl describe command for this pod. Okay, so the first thing I'm going to do is I'm going to add pod presets to the admission controller list of plugins. So comma pod preset. You have to be careful with the case. It's case sensitive. Pod preset. That's done. And I'm going to add one more option. I'm going to add a runtime option to enable pod preset. So I'm going to go to the browser and search for PodPresets Kubernetes. Go to the first link from kubernetes.io, enable pod preset. So we have to enable this runtime config option, which is this one. So I'm going to copy from here, runtime config set equals true. Copy that, and you can paste it anywhere in this arguments list. So let me go here and paste it. Okay, so that's all needed. Settings.k8s.io v1 alpha 1 equals true. Okay, so if I save this now, and you will see this Kube API server kmaster will get updated. So at the moment it says the master, this API server container or pod is running for 3 hours and 49 minutes. Okay, let's do that again. Get pods. Okay, Kube API server, it hasn't detected the change yet. Let's do that one more time. kubectl -n kube system get pods. Okay, so now you can see it's pending, and it's not in the ready state, the API server, and it has changed its state in the last 8 seconds. Let's run that command again. So it's running now, Kube API server, and it's in the ready state and it's running. So now if we do the describe command, kubectl -n kube system describe pod Kube API server -kmaster. Okay, look at the options list to the Kube API server command, and you can see that's the option that we added, and the enable admission plugins. So we've got PodPreset there. Okay, so that's how you enable PodPreset in your cluster. Now if I do kubectl get PodPreset, and it says no resources found because we haven't deployed any PodPreset yet. Okay, cd to play directory, and I'm gonna git clone my Kubernetes repository. Git clone the Kubernetes repository. The link will be in the description if you want to download or clone. Cd to Kubernetes, cd to YAMLs, ls. Okay, so I've got these three YAML files. Let's take a look at the first one, PodPreset1.yaml. Okay, it's a very simple one. It's not a big one. A very simple and straightforward one, right? Okay, so the API version is settings.k8s.io v1 alpha 1, which we enabled in the Kube API server runtime configuration. And then the kind is PodPreset. Metadata, the name of the PodPreset that we are going to deploy in our cluster is app1-env. And this is the important bit, selector. So whatever you do in this PodPreset, whatever you configure in this PodPreset, which pods it should apply to. So that's basically determined by this section here, selector, match labels, role app1. So any pod you deploy in your cluster with a label role equals app1 will get this customization. So what we are doing in this PodPreset, we're just setting up an environment variable with the name channel and with the value just me and open source, right? Okay, so let's deploy this. kubectl create -f podpreset1.yaml. Okay, so that pod preset is created. kubectl get pod presets. So we've got one pod preset. kubectl describe pod preset app1n. Okay, so that's the pod preset, and we've got one environment variable channel, and the value is just me and open source. So now if we deploy any pod that has a label role equals app1, that pod will have this environment variable inherited from this pod preset. So why are we doing this pod preset thing? Okay, imagine that you want to inject an environment variable or you want to mount a directory inside every single pod. You don't have to do it inside the pod spec. You can just create one pod preset and you can apply the label selector, and it will get applied to all the pods which has the matching labels. So it's like a template. It's easy for us to deploy multiple pods that require the configuration. And if you want to change, you don't have to go about changing every single pod. It's just one place, pod preset, and it will get applied to all the pods with the matching labels. Right, so where are we now? So we have done the pod preset enabling. We have ran through the pod manifest. We deployed the pod resource, and now we are going to deploy a sample app. Okay, so I always do the Nginx app because that's by heart. If you want to create a manifest, the easiest way is to do this: kubectl create deploy nginx --image equals nginx -dry run -o YAML, and if you do that, you will get the manifest file. So it hasn't done anything to our cluster. We specified dry run and the output in the YAML format. So I'm going to redirect that to a temporary file, nginx.yaml, and now I'm going to edit that file. /temp nginx.yaml. Okay, so that's the deployment. We don't need the creation timestamp. We don't need the strategy. We don't need creation timestamp, and we don't need resources, statuses. So that's a very simple manifest. You should be familiar with this type of manifest from my videos. Okay, so we are creating a deployment, and the deployment name is nginx with one replica, and the container image is going to be Nginx, right? Okay, so now we are going to apply a label to the pod, not to the deployment specification. So this is deployment specification, and this is the pod specification label, and we're going to add the label role is app1. So that's what we want, because that's what we defined in the pod preset. So whatever pod that has the label role is app1, the pod preset will get applied. Okay, so now if I run this, create this deployment, create -f temp nginx.yaml, deployment created, kubectl get all, container is getting created, kubectl get all. Okay, still the container is getting created. Let's wait for a few more seconds. kubectl get all. Okay, so the Nginx pod is running now. So there are a couple of ways to test whether the pod preset has been applied. One way is kubectl describe pod nginx. If I pipe that to less, you will see this annotation here. So pod preset admissions and the name of the pod preset that we applied, which is app1env. So which means pod preset has been applied to this pod. And you can, if you scroll down, you will see the environment here. Channel, which is Justmeandeopensource. We haven't defined that in our pod specification or deployment specification, so this has come from the pod preset. So I hope this clears some of your confusion as to how pod presets are used and what's the use of pod preset and so on. The other thing we could do is kubectl exec pod nginx --bash. So kubectl, we don't need the pod keyword. Okay, so kubectl exec, we are getting a shell in the nginx container. Why? kubectl exec nginx bin bash. Nope. Okay, let's go for shell then. kubectl exec. I know why we need to specify that it is an interactive shell. kubectl exec -it nginx --bash. Okay, cool. So now we have a shell inside our container, and if I do echo $channel with $N. Okay, Justmeandeopensource. So that's the other way of testing. So you've defined a configuration in a pod preset, and you've created a pod, and then the pod preset got applied to that pod. So that's how it works. Okay, let's try and create another container and see if that works. I'm going to edit the same file, temp nginx.yaml. I'm going to change the deployment name to nginx2, and I'm going to leave everything the same. kubectl create -f nginx.yaml. Okay, so kubectl get all, container is getting created, and this is for the deployment nginx2, and the pod is nginx2. Okay, container is getting created. Okay, container is running now. Let's do the same testing. kubectl describe pod nginx2, pipe that to less, and you can see the annotations that the pod preset has been applied to this pod, and the name of the pod preset that was applied is app1env. And if I scroll down, there's this environment. Channel is Justmeandeopensource. Right. Now I'm going to edit the same file, nginx.yaml file, and I'm going to remove the label role as app1, just to test that the pod preset doesn't get applied to this pod because we don't have the label role is app1. I also need to change the deployment name because we have already got a deployment named Nginx2, so this time it's Nginx3. kubectl create, okay, watch -x kubectl get all. That's running. Let's do a quick verification. kubectl describe pod Nginx3, pipe that to less, and you can see annotations, none. Let's see if there is any environment variables set. There are no environment variables set, right? Cool. So that has worked. So it only applies to pod that has the matching label that you defined in the pod preset. Let's delete all the deployment. kubectl delete deploy -all. So all the deployments have been deleted and the pods are getting terminated. Okay. What else? So we have done this bit with the labels, and we have done this one as well. So now we are going to test deploying a sample and add labels after the creation. I should have done that before deleting the previous deployment. That's okay. Let's do this one now. So I'm going to deploy a sample app without any label attached to it, so the pod preset won't get applied. And then I'll try and add a label. I'll try and attach a label to the pod and then see if the pod preset gets applied dynamically. It won't, but just let's give it a test. kubectl get pod preset. So still we have the app1n pod preset that injects the environment variable into all the pods with the matching labels. Vi temp nginx.yaml. Let's change that to nginx, and it hasn't got any labels yet. kubectl create. Okay, so that's getting created, and the pod is running now. kubectl describe pod nginx. Annotations, no. Labels, it hasn't got the role app1 label, so the pod preset didn't get applied, and there is no environment variable set. Environment is none. Excuse me. Okay, now let's try and attach a label to the pod. kubectl get pods --show labels. So it hasn't got that label, so now let's try and add a label to that pod. kubectl edit pod nginx. I'm going to add a label. Let's go to the very top. Label. Role is app1. Okay, pod has been edited. If I do kubectl get pods --show labels, the pod has now got the role is app1. Does it mean it has applied the pod preset? Let's check. kubectl describe pod nginx, and you can see still the annotation is none, no annotations, and no environment variable. So even if you add a label to the pod after it has been created, the pod preset won't work. It is an admission controller plugin, which means when you create a request to create a pod, it's only during the creation time that the admission controller kicks in and then inspects the request and injects this pod preset into your pod manifest. So it won't work that way. Okay, let's roll back that. kubectl edit pod. I'm going to delete the role, and if I do show labels, we have removed the label. So now let's edit the deployment and try and add the label to see if that works. kubectl edit deploy nginx. So now we are not deploying. So now we are not editing the pod directly. We are editing the deployment, and see what happens. kubectl edit deploy nginx. So metadata label, so this label is for the deployment. We're going to go down to the pod spec, and here is the label that we need to add for the pod. Role is app1, and if I save that, edited, and you can see the deployment has got the change, and it has created a new container and it removed the old container. kubectl get pods show labels, and you can see role equals app1. kubectl describe pod nginx, pipe that to less, and you can see the pod preset annotation and the environment variable is there, right? But the problem is when you update your deployment, it's going to kill your existing pod and then recreate it, which means the new pod that's getting created will get the pod preset configuration, because the pod is being created and the pod preset gets applied only during the pod creation and not dynamically. Okay, let's delete that. kubectl delete deploy nginx. Okay, so what else? Applying multiple pod presets. So you're not confined to just one pod preset. You can create as many pod presets as you want. Let's try and create another pod preset. So let's see what's in the pod preset 2.yaml. vi12 pod preset 2.yaml. So in the previous pod preset manifest, we added an environment variable. So this time we are doing a volume mount. So I'm gonna mount the volume in /mydata in all the pods that has the label role app1. Okay, let's create this pod preset. kubectl create -f. Okay, kubectl get pod preset. So we have two pod presets, app1n and app1 mounts. So both of these pod presets applies to any pods with label role is app1. Okay, so I'm going to edit temp nginx.yaml. I'm going to add the label role is app1. So this demo is just to show you that you can apply multiple pod presets to the containers. kubectl create -f temp nginx.yaml. Okay, container is getting created. kubectl describe pod nginx, piping that to less. You can see two annotations now, pod preset, and the name is app1n and the second one is app1 mounts. And if I scroll down, you will see that /mydata is mounted from the web volume, which is an empty dir, and the environment from the other pod preset. So you can apply multiple pod presets to the matching pods. Okay, kubectl delete deploy nginx. And I'm also going to delete one more pod preset. kubectl delete pod preset app1 mounts. Okay, so we've left with one pod preset. So next what I'm going to show you is the conflicts, pod preset conflicts. Two pod presets with the same configuration. What happens when you have two pod preset with the same configuration but with different values? What I mean is, so I have this pod preset 1.yaml, which is trying to inject an environment variable named channel with a value Justmeandeopensource. And if I look at another pod preset, it's also trying to inject the same environment variable channel but with a different value. So in this case, which one wins, which one takes precedence, that's what I'm going to test now. Okay, let me deploy this pod preset. kubectl create -f. Okay, kubectl get pod preset. We have two pod presets, one with environment variable channel set to Justmeandeopensource, the other one is channel set to hello world. Okay, so vi temp nginx.yaml. I think it's good. So both the pod presets that we have here applies to pods with label role equals app1. Let's try and create that. kubectl create -f. Okay, so it's creating, container is getting created. So we have a pod conflict at the moment, right? Let's see what happens. kubectl describe pod nginx, and you can see annotations, none, which means none of the pod presets has been applied to this pod, and there is no environment variable or there is no mount from the pod preset. So that's what happens when you try to add two pod presets with a conflict, right? Okay, so the other thing I wanted to show you is pod preset with configuration already in the pod. So for example, kubectl get pod preset. Let me delete n1. Okay, so we are left with just one pod preset, and that pod preset, kubectl describe pod preset app1n. So that pod preset is trying to set or inject an environment variable named channel and the value as just me and open source. And if you have got your pod with the same environment variable configured as part of the pod manifest, the configuration that you defined in your pod manifest takes precedence, so it will ignore the pod preset now. Okay, let me show you a quick example here. If I edit the nginx.yaml, so role is app1, so it's still going to fetch the configuration from the pod preset. And let's try and do one thing here. In the container section, I'm going to add an environment variable here. And the name of the environment variable is going to be channel, and value is going to be this is set inside the container. So I'm setting the environment variable in the pod specification with the same environment variable that I've defined in my pod preset. So let's see which one takes precedence. kubectl delete deploy nginx. kubectl create nginx. Okay, so that's getting created. Let's see what happens. kubectl describe pod nginx. Pipe that to less, and you can see annotations, no annotations, because the pod preset hasn't been applied. And if you scroll down, you can see the environment variable channel. This is set inside the container. So if you specify the same configuration within the pod manifest, within the pod specification, that one takes precedence and it will ignore whatever you defined in the pod preset. Okay, kubectl delete deploy nginx. And finally, check if it works across the namespace. As you would imagine, it won't work across the namespace because if I do kubectl get pod preset -n kube system, it's not there. The pod preset we have defined is only available in the default namespace. You can define a pod preset in any namespace, but it only works for the pods that are created within the same namespace. So let's try and create kubectl get pod preset. So still we have the app1 env pod preset that's created in our default namespace. And if I edit nginx.yaml, actually we don't have to edit it. Either you can add the namespace option here, namespace kube system or something, or you can dynamically create give the option when you're running the kubectl command. So bear in mind, still we have the label applied. Role is app1. I don't want to edit this. Okay, so we haven't touched the nginx.yaml file. Let's create a new namespace, kubectl create namespace testing. kubectl get namespace. So we have the testing here, and we have defined our pod preset in the default namespace. So now let's try and create the Nginx deployment in the testing namespace. kubectl -n testing create -f nginx.yaml. Okay, so that's created, and you can see in the default namespace the container didn't get created. It will be in the testing namespace, testing get all. Okay, the container is running, Nginx container. Let's see if it has pulled the pod preset. It wouldn't have, as you imagined. kubectl -n testing describe pod nginx pipe that's less. Annotations none, and there is no environment. This environment, that's because we didn't change the one here. Okay, let's delete that. kubectl -n, let's start again from scratch. kubectl -n testing delete deploy nginx. Okay, that's deleted. kubectl -n testing create -f. Okay, that's created. If I do kubectl -n testing describe pod nginx 5 that's less, no annotations, and there is no environment. So this is just to prove that the pod preset doesn't work across the namespace. If you define a pod preset in a namespace, it will work only with the pods that are created with the matching labels in the same namespace. Cool. I think that's all I wanted to show you. It's a very simple concept, but it will come handy in many situations. Yep. So basically that's it. If you've got any questions or comments, just let me know. So thank you so much for your time watching this video today, and I hope to see you all in my next video. Bye bye.